Hello everyone. So today we are going to have one more very interesting problem in our lead code, which is called search a 2D matrix. So let's quickly read the problem description and see how we solve the question. So this is the problem which says you are given an m cross n integer matrix with the following two properties. First property is each row is sorted in non-decreasing order, okay, meaning ascending order, and then the first integer of each row is greater than the last integer of the previous row. So first integer of the each row, so every integer in the first each row is greater than uh, the last integer of the previous row. All right, so this is always greater than the last integer of the previous row. So 10 is greater than 1 and things like that. You must write solution in O log m cross n, time complexity. So before that, uh, let's check it out like what we have to do. Okay, so given an integer target, return true if target is in the matrix or false otherwise. So it simply means that you are performing a search into the 2D matrix, right? So if this is the matrix 1 3 5 7, this and target is 3, so you just need to say if 3 is found or not. So this is found, so uh, the answer is true. Okay, and if the target is in the matrix not found, then you say the answer is false. For example, here it is 13 and 13 is not found. So I think it's a very easy question when it comes to a brute force solution. As I always emphasize that whenever we solve any question, it's always good to have the brute force approach first. Take 2 minutes of time, discuss the brute force approach with the interviewer, and then quickly jump to the optimized. I mean, when you code for the optimized version of the solution. This is always, should be the best practice um, to get good score when you are having a data structures and algorithm interview questions in front of you. So, yeah, so I think to find a number in a matrix is very easy here. You can have two loops because matrix has rows and columns. So you can have I comma j and then two nested loops, and then you can just check if if the target element is found in for example, if it is a matrix, so matrix I j is equals to target, then return true, otherwise return false. Very simple, right? But the time complexity of the solution would be O of m cross n. And you see here, they have explicitly written, hey, you have to solve this in log m cross n. Okay, so we cannot solve it in O m cross n. Now, how we can get this time complexity, which is log of m cross n? So see, in the problem statement itself, there is something that you can take always as a given. So I tell you one thing which is very common, and you can have it as like kind of a trick. You can memorize it whenever there is anything related to sorting given in any question, either it is non-descending, descending, and all that. You should always, think first that hey, the optimized version, because there is sorting already done, so we can definitely optimize the solution to any log and log numbers. So, for example, log m cross n or something like that, right? Well, how we do that trick here in this particular question, that is something which we need to understand. So let me quickly do it this way. I just copy this all, go to my IntelliJ, and I just write this. Let's say the class of my uh, search metrics. All right. So this is, here we go. So this is our question. And now I'm gonna code this. So before I did this, I just need to first copy this matrix. So I go here. So let me copy this matrix. So let me copy this matrix. So let me copy this matrix. Okay. And now I just write main method. Here we go. And my input. logic and output. So here's my input. Okay, so this is my input. So it is an integer matrix. So all right. So I just need to do this. I need to replace all this with curly braces because this is what Java understand. And then this is all done. And then I say int target is equals to 3. Yeah, so this is my input, right? Now, as I said, you can have brute force solution. You should always discuss the brute force solution, which is m cross n. So if you need to find target inside this matrix, it's very easy. You just need to iterate two nested loop into this matrix, and wherever matrix I j is equals to target, you just return true. If not, then return false. So this is very simple. But here we are going to use an optimized solution because the expectation is you need to find the solution in O log m cross n. So what logic? Let's quickly do this way. I will first say result is equals to, and then I will say search matrix. Okay, and there I will pass matrix comma target. All right, and then I will just print here result. So now we have to make this method. Here we go. This is our method, right? Now brute force you already know. Now I'm going to work on this solution which is optimized version, taking the advantage that the matrix is already sorted in ascending order, non-decreasing order. So when we say ascending order, so I mean decreasing order and increasing order. So you always need to understand that uh, ascending is like from smallest to biggest, and then descending is from biggest to smallest, right? Okay, so what we have to do, we just first need to so what like the approach here is simple, that we treat the matrix as a single sorted array and use binary search. All right. So we treat the whole matrix as a single sorted array because why? Because it's written that each row is sorted in non-decreasing order, which is an ascending order, meaning smallest element first. So we can just assume that my whole matrix is a single sorted array, and then we apply the binary search there, and then always we get the solution in log some log times something, right? So whenever you are having a sorting in any input, you can always get the log when you are applying a binary search or binary approach in that particular problem statement. So there I'm treating my whole array as a single sorted array. I mean whole matrix as a single sorted array, and then I apply my binary search there in order to find the target element. So uh, let me frame it in a better way. So number of rows are matrix dot length. All right, integer calls matrix 0 dot length, and then we just do a while loop and we say left. Okay, so left and right we need to initialize. Int left is equals to 0, int right is equals to rows calls -1. Okay, so as I said, we are considering this whole matrix as a single sorted array. So if I just want to find out how many elements are there in my whole single sorted array matrix, it will be like rows times columns -1. All right. So that is the reason why I did. So if you are asking me for a single array, you always need left and right, correct? So left is 0, but what will be the value of right? Will be the total number of elements in the matrix, right? So rows times columns -1 is my total number of elements. Why? Because I'm treating uh, one dimensional array for my matrix. Okay. Now we have left right ready. It's very simple now. left is less than equal to right, and it's the same approach, like integer mid is equals to left plus right minus left by 2, and integer mid value is equals to matrix mid by cos. Okay, so this is I index, and then j would be mid percentage cos. All right. So maybe this line is very confusing, like mid value, how I'm trying to find out. See, when my whole uh, two-dimensional matrix is converted into one dimensional array, and then if let's say if I have to find one single particular value at particular index, right? So how would I find that? So this is very simple maths. If you just look at here, mid by calls will give you the index I index of that particular matrix, meaning I index, and then this mid percentage calls will be the j index of your remainder matrix, right? So in that case, you will always get, you convert 1D index to 2D. So this is what we are doing. We are converting 1D index to 2D. All right. And that is the reason why we are doing that. And now it's very simple. Like if mid value is equal to target, return true. All right. Else if mid value less than equals to target, we just do left is equal to mid plus 1, or else we do right equals to mid minus 1. All right. So this is a very simple and straightforward. Like I think most of us, we have already done that. This thing, it's just a matter of repeating again. So with one dimensional array, let's say you have one dimensional array which is sorted array in ascending order. You need to find a target there. It's very simple. You apply binary search, you go and find the mid, you do this line number 33 always, and then you try to find out the value. So in case of normal array, you just write array and then you get the array of mid, and then you get the element. But here it is 2D dimension, right? So in two-dimensional array, you're considering this 2D dimensional matrix as a single sorted array. So there you have to convert 1D index to 2D, and this is how you do that. And then everything else is same, and then you return false here, return false. Yeah, and so that is so now let me run this and see how the solution looks like. Yeah, so it returns true, which is correct. And let's say if I write 13 here and then I run it again, so it returns false because 13 is not found, right? So that is pretty much all. I mean, this solution here, which is very simple, not brute force like a binary search approach. It's the technique only was just you need to treat the whole matrix as a single sorted matrix, and this is also you need to play around with the indexes, right? It is not only one single sorted matrix. It's a matrix wherein you have to convert 1D index to 2D, then only, and then the time complexity of this solution would be time complexity would be O of m cross O of log m cross head. All right. So this is my time complexity. So I hope you like this solution. We will run this solution and see how it runs into the LeetCode. Control C. Here we go. I just paste it here, run it. Okay, so it is accepted. We submit this. It's submitted. So thank you very much. I see you in another video.